Okay, for functions part 3, we're just going to run through some more examples and just see some different types of scenarios that you might see when evaluating functions or when working with functions. The first ones we kind of did already in part 2. Evaluate a function given an input. Okay, so we have 3 functions here. F of x is negative 2x plus 3, g of x equals 6x minus x squared, and h of x equals x over 2. So we're going to find f of 10, g of 10, and h of 10. Remember, when you're evaluating a function, all you have to do is go to that function's name, whichever one's being called. In this first one, it's function f. And so you go to function f, and wherever you see the input value, which is x, we're going to plug in 10. So instead of negative 2x plus 3, we're going to have negative 2 times 10 plus 3. And then simplify. It's always the last step of a math problem is simplify. Negative 2 times 10 is negative 20. Negative 20 plus 3 is negative 17. Okay. So f of 10 equals negative 17. Okay. Same thing for g. G of 10. Go to function g, and wherever you see x, you plug in 10. Now in function g, there's 2 occurrences of x. So we're going to plug it into both of them. So g of 10, again, g of x is 6x minus x squared. So instead of 6 times x, we're going to have 6 times 10. And instead of minus x squared, it'll be minus 10 squared. Okay, and simplify. So that's going to be 6 times 10 is 60. 10 squared is 100. 60 minus 100 is negative 40. So g of 10 equals negative 40. And lastly, h of x is x divided by 2. So for h of 10, we're just going to take that x and plug in 10. So instead of x divided by 2, it's going to be 10 divided by 2. 10 divided by 2 is 5. So h of 10 equals 5. Okay, so that's if you're plugging in a number. You could also evaluate functions when you plug in an expression. So these are the same 3 functions. But now we're going to find h of 12c, g of 5w, and f of 3z plus 1. Okay, it's the same thing. The function call tells you what the input is. So the input on this first one is 12c. Okay. So we just go to function h, and instead of x, we're going to input 12c. Okay. So h is x divided by 2, so we're going to have 12c divided by 2. Okay. And simplify if you can. Some of these you can simplify, some of them you can't. 12c over 2 is 12 divided by 2, which is 6. So it's 6c. So it doesn't have to be a number answer. It could be in just another expression. On the second one, g of 5w, go to function g, and wherever you see x, we're going to plug in now 5w. So it's going to be 6 times, instead of x, 5w, minus, instead of x squared, it'll be 5w squared. Okay. Simplify if you can. Okay. Well, 6 times 5w is 30w. And then minus 5w squared is minus 25. You square both terms. So minus 25w squared. Okay. So we're just left with another expression. And notice that the variables change. When you change the input variable, the variable overall changes. All right, and the last one, go to function f, and wherever you see x, in function f, you're going to plug in 3z plus 1. Okay. So instead of negative 2 times x, we're going to have negative 2 times the new input, which is 3z plus 1. Okay. And then don't forget the plus 3 at the end because it's still part of function f. Okay. So again, all we're doing is changing what used to be here, there used to be an x here, but since we changed the input over here, we have to change the input over there. Okay, so same thing except we're replacing x with 3z plus w. We could simplify this by distributing. Gives us negative 6z. Negative 2 times 1 is negative 2. And you still have that plus 3 at the end. So we could even go further and combine like terms now. So negative 2 plus 3. Okay, so negative 6z plus 1 is going to be the simplest form simplified. Okay, so we see we could evaluate functions when we input numbers or expressions. Another thing you might see is in those previous problems we gave you an input and you found the output. You could also go the opposite way. You could be given an output and you have to find the input. Okay, so this could be written a couple of different ways. All right, so we have a function f of x equals negative 2x plus 3. And the problem says that if f of x equals 13, find x. Okay, f of x equals 13. That 13 is the output. Okay, so when it says find x, it means find the input. Find which input is going to give you an output of 13. Okay, so we're just going to kind of translate this expression, f of x equals 13. Well, we know what f of x is. F of x is negative 2x plus 3. So if f of x equals 13, that means that negative 2x plus 3 equals 13. And that's just an equation. That's just a two-step equation. We can solve for that. Okay. So again, we knew f of x. F of x is negative 2x plus 3. If f of x equals 13, then negative 2x plus 3 equals 13. So we'll just solve for x. Okay. Two-step equation. Subtract 3, divide by 2. And you end up with x equals negative 5. So again, that was two-step equation. Subtract 3, divide by negative 2. Okay. Now sometimes in problems like that, you might see it where they switch the variable. So that one just said f of x equals 13. Find x. They could also switch the variable on you. So in this problem, we have a new function, g of x equals x divided by 7 plus 1. And the statement says, if g of k equals 5, find k. Okay, so it's no difference, but they're just saying, all right, we input this variable, this different variable k, and output is 5. So find what we input, find what k is. Okay. Go about it the same way. G of x is x over 7 plus 1, which means g of k would be k over 7 plus 1. Okay. And it says it equals 5. Okay. So g of k equals 5, so k over 7 plus 1 equals 5. And then again, just solve for k, find that input. So in this one, two-step problem, subtract 1, multiply by 7. Gives you k over 7 equals 4. Times 7 on both sides. And you end up with k equaling 28. So again, what that means is when you input 28, you're going to get an output of 5. Okay. But on that problem, they gave us the output. So the k value of 28 gives you the output of 5. G of k equals 5, k equals 28. You can also perform operations with functions. Okay. Now there's two things you'll see. You'll see them separate or you'll see them combined. In a separate one, you just find each separate function and then do the operation in between. So it's kind of a problem within a problem. On this one, we have three new functions. F of x equals 3x, g of x equals x minus 5, h of x equals x over 2. Okay. And we need to find f of 4 minus h of 20 plus g of negative 8. Okay. So we'll just go through and find each of those separately. Okay. F of 4, okay, well, f of x is 3 times x, so f of 4 is going to be 3 times 4, which is 12. Okay. Minus h of 20. H of x is x over 2, so h of 20 is going to be 20 over 2, okay, which is just 10. Okay, now again, the operation there was minus, so this one's going to be minus. Okay, and then find the last piece, g of negative 8. Negative 8 is our input. Plug it into x in function g. So instead of x minus 5, it's going to be negative 8 minus 5. Negative 8 minus 5 is negative 13. Okay. And then keep the sign. So it's plus minus 13, plus negative 13 is just minus anyways. So 12 minus 10, minus 13. 12 minus 10 is 2. 2 minus 13 is negative 11. Okay. So if they're written separately like that, you just do them separately and then do whatever operation is in between them. You might also see them combined in something like this. So this one is f plus g of 3. All this means is f of 3 plus g of 3. Okay. So if you see it like this, the input has to be the same in both. Okay. So it's going to be a 3 in both of them. Okay. The one above it, when they were separate, you could have separate inputs in each function. But if it's in combined form like this, it just means f of 3 plus g of 3. Okay. So our functions are the same. Function f was 3 times x. So f of 3 is going to be 3 times 3. Okay. Plus function g of 3. G was x minus 5. So g of 3 is going to be 3 minus 5. Okay. Simplify and solve. Okay. So 3 times 3 is 9. Plus 3 minus 2, or 3 minus 5 is negative 2. Okay. 9 plus negative 2, or 9 minus 2 is 7. And you can see that with any operation. F plus g of 3. This one is h times f of 5. Okay, so again, same thing. All this means is h of 5 times f of 5. Okay. Function h was x over 2. Okay. So h of 5 is going to be 5 over 2. Okay. F of 5, function f was 3 times x. So f of 5 is going to be 3 times 5. Okay. Simplify this one as a fraction, but that's okay. It's just 5 over 2 times 15. Which is not a great fraction, 75 over 2. And just multiply the top times the whole, leave the bottom. A new type of operation that you're not familiar with is called a composition. Okay. All a composition is it's basically a function inside of a function. We have two new functions here, f of x equals 2x plus 1 and g of x equals 3x. So what a function in a function looks like, a composition, is it looks like this. Okay, so we're going to find f of g of 2. Okay, we're going to start by evaluating g of 2. Okay, start on the inside. So g of 2 equals, well again, go to function g, plug in 2 for x. So instead of 3 times x, it's 3 times 2, which is 6. Okay. So g of 2 is 6. G of 2 is 6. So really what we're trying to find now is we're trying to find f. So we have f of g of 2 but we know what g of 2 is. Okay. We found that g of 2 equals 6. Okay. So we could replace this whole g of 2 part with 6. Okay. So instead of f of g of 2, we could just find f of 6. So you just evaluate one function and then plug it into the other function. So now we're finding f of 6. F of 6, you'd go to function f, and wherever you see x, you're going to plug in 6. So that's going to be 2 times 6 plus 1, which is 13. Okay. So just evaluate the inner function. Whatever you get, that's going to be your input for the outer function. Okay, so that was f of g of 2. What if we switch the order and when we want to find g of f of 2? Well, you would do the same thing. Start with the inside function. Start by finding what f of 2 is. Okay. F of 2, go to function f, plug in 2. So f of 2 is 2 times 2 plus 1. Which is 5. Okay. So now what we're doing is we're trying to find g of that inner function, which was 5. So we're finding g of 5. Okay. So your first output becomes your second input. That's a good way of thinking of it. So we're finding g of 5. G of 5, go to function g, plug in 5 for x. So instead of 3 times x, it's 3 times 5. And g of 5 is 15. So you don't get the same answer. Having g go first gave us 13. Having f go first was 15. Okay, so for all those, we were given a function. Okay, we were given an equation in that function. Sometimes you won't be given that. Sometimes you might be given one of the other ways we can write a function, which include graphs, tables, ordered pairs, mapping diagrams. In these, we're given a graph. Most of the time it'll be a graph. In this case, we're given a graph and we're asked to evaluate from the graph. So find f of 2. Okay. Remember what the input means. The input's the x value. So when you're trying to find f of 2, you're trying to find what y value occurs when your x value is 2. So if you're given a graph, you would just have to find x equals 2 on the graph, which is 2 over on the x-axis, which is going to be right here. And you got to figure out where's your graph, where's the dot. Okay, on a discrete graph, you're looking for a dot. On a continuous graph, you'd be looking for, where's your line. So our graph is right here. Our dot is up here. What's the y value at that point? The y value, when your x value is 2, is it's up 1, 2, 3. So f of 2 is just 3. So that's when you're given the input, find the output. You're given an x value, find the y value. The opposite can be true, just like when we were doing it with the equations. Find x when f of x equals -4. Okay? So find the x value when your y value is -4. So for this, you're going to have to go to the y value first. Okay? So we're going to go down 4 on the y-axis. Okay, that's right here. Find out, look to the left and look to the right. Where's the graph? Where's your dot? It's out here. What's the x value at that point? Well, it's 1, 2, 3, back 3. So the x value, when f of x equals -4, your x value would be -3. Okay. So if you're looking for an output, go to the x value, find the y value. If you're looking for the input, go to the y value and find the x. Okay. So that's from a discrete graph. What if we have a continuous graph, like I said? Okay, continuous graphs have connected dots. Okay. Same thing. We're looking for an input of -3. What's the output? So when your x value is -3, what's your y value? So on your graph, you have to go over 1, 2, 3. where's the graph? So you look up and you look down, where's the graph? The graph is down here. What's the y value down there? 1, 2, 3, -3. So f of -3 equals -3. So we found -3 on the x-axis, and then we looked for where the graph is, how far up or above it is. Same thing on the second one, except now the opposite. Find x when f of x equals 3. Okay? So find the x value that'll give you a y value of 3. So you have to go to the y-axis and go up 3. Okay, that's right here. Now if you look to the left and to the right, there's 2 spots that work. That spot's at 3, and that spot is at 3. So this one has 2 answers. So 2 inputs are going to give you an output of 3. That's still a function, though. Remember that to be a function, each input can only have 1 output. Okay. But the outputs could have multiple inputs. Okay. So there's 2 occurrences. There's 2 things that work. So let's find them. When x is back, let's see, 1, 2, 3, 4, -5 works. So when x is -5, your output is +3. And your second answer is when x is over 1, 2, 3. When x is 3, your output is 3. Okay, the last function is, the last scenario is talking about functions in context. Okay. So this is a scenario. It could be a number of different scenarios, but in this one, a ball is thrown into the air, and its path is modeled by the function h of t equals -t squared plus 5x, that should be t, plus 5t, plus 7. Remember, your input variable has to stay the same throughout. Okay, where t is time in seconds and h is height in feet. Okay, so the first question says find h of 4. Okay, well, we know how to do that. H of 4, we're just going to go to h of t, and wherever we see t, we're going to plug in 4. Okay, so instead of -t squared, it's going to be -4 squared plus 5 times t, so that's going to be plus 5 times 4, and then plus 7. Okay. And then simplify. H of 4 is going to equal, well, 4 squared is 16. That negative's on the outside, so it's -16. Plus 20 plus 7. H of 4 equals 11. But the second question asks, what does h of 4 mean? Okay. Remember what the variables meant. The variables meant t is the time in seconds, and h is the height in feet. Okay. So h of 4 is the height after 4 seconds. H of 4 is the height of the ball after 4 seconds. And we know what h of 4 is because we just found in the previous problem. The height after 4 seconds is 11 feet. So that's the height of the ball after 4 seconds. So you'll see scenarios like that, and some they'll give you the output and you have to find the input and then explain what that means as well. So this is just a bunch of different scenarios for evaluating functions. We could do it in context. You could evaluate with numbers. You could evaluate with expressions. You could evaluate from a graph. You could use the operations. You could do compositions. So a bunch of different options now.